Today, we are going to solve a problem. My name is Dr. Yap Banha, and I will share a problem with you. The problem is this. There are 4 friends: Spiky, Curly, Smiley, and Bunny. And their art teacher wants them to share a piece of art paper like this one. It's in the shape of a square. So that's the problem. 4 friends needs to share a piece of art paper so that everyone gets the same amount of paper. 4 friends need to share a piece of art paper equally. Let's think of different ways they can do that. You have many pieces of square paper. They are all smaller than the actual art paper. But you have a lot of this, and they are all squares. What else do you have? You have a pair of scissors, so you can do whatever you want, including cutting up the paper. And you have rulers and the usual stationery. Why don't you and your friends go and explore different ways to solve that problem? Remember, we always want to have many different ways to solve a problem. Perhaps there's method 1, method 2, and maybe on clever days, we might have method 3, method 4, method 5, and so on. Also, as usual, remember, when you work with your friends, we agree to listen, but we do not need to agree. Let's begin. Hello colleagues. In this video, I show one possible way to present an anchor task. After presenting the anchor task, let the children work among themselves in groups. Give them some time. Give them the freedom to explore. Give them the chance to talk about the problem using their own childlike language. Give them concrete materials that they can use. Allow them to draw. That is one way we can present an anchor task for students to learn the concept of equal parts. Our problem today is about 4 friends who need to share a square piece of art paper equally. What are some of the methods that you and your friends came up with? Is that right? You managed to get one where everyone gets a square? Is this the one? But how do we know that all of them receive the same amount of paper? Is that right? We can fold to check. You mean like so? So if you fold the art paper and they overlap, the pieces overlap each other exactly, the pieces meet corner to corner, we can say that the amount of art paper are all the same. I suppose that's one way to check. Is there another way to solve the problem? Did someone say that all of them receive rectangles? Is that possible? Can you imagine how the 4 of them can share the art paper such that everyone gets a rectangle? Do you mean this? How can we check that the 4 pieces are all the same amount of paper? Sure, we can fold as before. Is there another way to check? Oh, cut them out? You mean like so? And what should happen when we cut them out? Yeah, you get pieces. You get 4 pieces. But how can we show that the 4 pieces are all the same amount of paper? What can we do? Can you tell your friends what we can do to show that the 4 pieces are all the same amount of paper? Is that right? You can put them one on top of the other. And when you put them like so, the pieces all overlap exactly. And the corners meet with each other. Is today a clever day? Is there a third way to solve the problem? Everyone gets a triangle? Like this one? Can we check by folding? Can we check by cutting out the pieces and put them one on top of the other to see whether or not they overlap exactly? Why don't you try? Oh, someone thinks that we can get a different way, but everyone still gets a triangle each, but different from the way before? Is that possible? Can you imagine how the 4 of them can share the paper so that everyone gets a triangle, but not like the way before? Do you mean this one? Oh, someone else have a different solution. Do you mean this one? Some of us may think that these 2 are different ways to share the art paper. Some of us may think that both of these ways are actually the same way. Of course, we're entitled to our own opinions, so long we can explain ourselves. So it's up to you whether you want to say that both these methods are the same or they are different ways to share the art paper. Can we check by folding? No? So how can we show that the 4 pieces of art paper are the same amount of paper? Can we cut them out and put them one on top of the other to show that they overlap exactly? Why don't you try that? Are there other possible ways? Hello, colleagues. What are some responses that we anticipate the students to come up with? One category of responses are methods that can be verified by folding. Like this one, that one, and this one. Of course, they can also verify the solution by cutting the shapes out and put the shapes one on top of the other to see if the shapes match each other exactly. Another category of responses are those that cannot be checked by folding alone. They need to cut the shapes out, like these ones. Students may also come up with possibilities like that. But you do not normally expect everyone to be able to do this one. Simply because to generate that possibility, students need additional skills. In this case, the technical dexterity to make sure this length is equal to that length, also equal to this length, and that length. While the other solutions can be obtained by folding, that many young children can do, this solution requires that technical ability to measure in order to generate it. What are the other responses that you expect some students to be able to come up with? Some students might generate responses where different people get different number of pieces. So they may say that Spiky gets that triangle, Curly gets that triangle, but Smiley gets two triangles. These two triangles. And likewise, Bunny, she gets those two triangles. Another category of responses involve shapes that are not congruent to each other, like this one. So Spiky gets the square, Curly gets a rectangle. So I wonder which method of checking might work. Can we check that the amount of paper are the same by folding? By cutting out? Or perhaps we need to invent new methods of checking. I wonder if there are other possibilities like so, starting with two of them receiving a square each. I wonder if there are other ways that remaining piece can be cut into two pieces that are equal in amount. Another category of response involve students initially folding the paper into, say, 16 little squares, like so. And from there, they generate shapes for the four friends to share. Like in this case, where the pieces are congruent to each other, or perhaps starting like so, where not all the four pieces are congruent to each other. I have started off that solution with a rectangle and an L shape. I wonder if you can continue to generate the other two pieces. So that category of responses begin with the students folding the square paper into 16 equal parts. Of the different responses children come out with, some of them we can check that the paper are all the same amount by simply folding, such as these three. And then there are some responses where folding cannot be used as a way of checking for equal parts, and we need to cut the pieces out, such as these ones. How about this one? Do you think folding will work? Or do we need the cutting out method? Yet other ways of checking. We can also check if the 4 pieces are equal by cutting the shapes up. So we might cut the rectangle out like so. But cutting out the rectangle alone is not enough to show that it is the same amount as a square. So we need to cut the rectangle up and then try to use the pieces we get to overlap with the square. Perhaps like this. Can you imagine how the 2 pieces that I get might overlap with the square eventually? So that's another way of checking, by cutting out and then cutting the shape up. So cutting up is another way of checking. And then there are some responses like this one, where we can check by counting squares. So among the different ways students might offer as to how they can check whether the 4 friends receive the same amount of paper include folding, cutting out, cutting up, counting squares. Are there other methods of verifying whether or not the 4 pieces are the same amount? How do we support struggling learners in the learning of any topic? If we take the ideas of deans, we should provide struggling learners with more opportunities in the exploration of the idea that they're supposed to be learning. Also, keep things informal. Avoid technical jargon and instead use everyday language. What other things can we put in place in our everyday lesson to support struggling learners? We can take the ideas of Piaget. Make sure there's ample processing time during learning. In other words, less is more. Give them an anchor task so that they are not rushing from one exercise to another. Give them an anchor task that they can spend ample time on to internalize the ideas and build the necessary schema. Also, Piaget's ideas let students use oral language in the initial acquisition of the concepts they're supposed to learn. What else can we do? We can listen to Vygoysky. Let students interact. Let students work with each other. The process of interaction and conversation is part of the process of learning something deeply. What else can we do? We can take a leaf out of Skemp's book. Skemp's idea emphasizes the importance of conceptual understanding. Make sure students are able to make meaning of whatever they learn, not just the steps, not just the procedures, not just the tricks, but the meaning behind whatever concept they are learning that day. Finally, we can also take the suggestions of Bruner the so-called CPA approach. Let students learn abstraction through concrete experiences as well as pictorial representation. C for concrete, P for pictorial, and A for abstract. Initial concrete learning that emphasize a lot on the use of visuals will ensure struggling learners have a fighting chance to access abstract concepts. Those are some things that we as teachers can do on an everyday basis to ensure we support them. Specific to the lessons they're supposed to learn, what can we do? The anchor task of 4 children sharing a square piece of art paper equally is used for students to learn about equal parts. How are struggling learners supported in this anchor task? Firstly, this anchor task have solution methods that are accessible to practically every student who are learning this topic. Methods like this, methods like this, and methods like this one, many students given pieces of paper are able to generate them. Another way to support struggling students is to use plain language. In presenting the anchor task, instead of saying 4 friends need to share the art paper equally, the teacher might say 4 friends need to share the art paper. Make sure everyone receives the same amount of paper. Through the use of plain language, students who might struggle with language of abstraction or language of instruction, they have a higher chance of accessing the concept of the lesson. In this case, the concept of equal parts. Instead of saying equal parts right from the beginning, the teacher said, "Are you sure the 4 pieces are the same amount?" And in this instance, students have rather accessible way to check whether or not the 4 pieces are indeed the same amount of paper. Of course, another way to say that in a more formal way is to say that the parts are equal parts. The anchor task is about 4 children sharing a square piece of art paper equally among themselves. Students should be able to generate 1 or 2 solutions pretty quickly. How can we challenge the advanced learners? A couple of ways at least. There are solutions like that to the anchor task. Advanced learners are challenged because they need to have a higher ability in visualization to be able to perceive a solution such as this, because the 4 parts are not obviously equal to each other. In addition, they need to have technical abilities like measuring in order to generate solutions like that. In this particular case, this length must be equal to that length, which in turn must be equal to this length as well as that length. Also, methods like that require more conceptual understanding that in this case, parts can be equal even though they are not congruent, because equal amount of paper is indicated by the area of the shape. And hence, even though the shapes are different, if they do have the same area, they are indeed equal parts. Likewise, in that solution, students should be able to rationalize why it is possible for someone who get one slice to be getting the same amount of paper as a friend who is receiving 2 slices. Advanced learners should have the ability to rationalize that one big piece can be equal to 2 smaller pieces. Advanced learners are challenged in this anchor task because there are solutions that demand higher degree of visualization, better understanding in conceptual matters, as well as additional abilities, such as doing measurements. Another way advanced learners can be challenged is through what-if questioning. What if? What if the art paper is not square? What if the art paper is a rectangle? Generating possibilities like that. In the case of a square, it is rather trivial why the 4 parts are equal. But in the case of rectangle, a solution that is somewhat similar requires greater amount of justification why that triangle and this triangle, both of which are not congruent to each other, are indeed equal in size. Similarly, we can challenge students by saying, what if the art paper is triangular in shape? How can you cut a triangular piece of paper into 4 equal parts? That is yet another way we can challenge advanced learners in this anchor task. Other than those suggestions to challenge advanced learners that are specific to that anchor task, what are some general strategies that teachers can put in place to challenge the advanced learners? The first strategy: write a note. Write a note to a friend who is absent from class how you solve the problem that we were solving in the anchor task. Write the note in your journal. It's one possible way to encourage our advanced learners who may be very good at doing the mathematics but need a bit of practice in articulating, in communicating, in explicating their mathematical ideas. Variation to writing a note could be: explain to a friend. Someone in the class may need your help. Why don't you help them by explaining to them your ideas that they themselves may not be able to understand? Another strategy to challenge advanced learners perhaps is to invent a method. In class, we have already several methods to solve today's problem in the anchor task. Why don't you, given that you are done with your work quite quickly, why don't you invent yet another method that, in your opinion, is better than the ones we have discussed? Invent a method. Some students may be pretty good in the content itself. However, they need to practice more in the area of being creative, coming up with unusual thoughts that may be better than the common ones. Another strategy teachers can put in place to challenge advanced learners is to invite them to pose a problem. Why don't you be the teacher and write a problem somewhat similar to the one we solved in the anchor task today, but make it slightly harder, and I will try to solve the problem afterwards. You might also want to include the answer to your problem on the next page so that I can check whether I'm right or not after trying to solve your problem. Pose a problem can be another strategy to challenge our advanced learners. Finally, we can invite advanced learners to investigate further the anchor task that they were solving as a class that day. You can invite them to pursue some what-if questions that they or you may have come up with. Those are some strategies we can use on a daily basis to challenge our advanced learners. How do we assess students' learning in a lesson? As a teacher, we need to be clear about the indicators that suggest that students have reached the targeted level of learning. For the lesson that we are discussing, for the anchor task that we are discussing, what is that targeted level of learning? And then we think about what are some things we need to see to suggest that students who are not yet at the targeted level, what indicators suggest that they are approaching that targeted level? And for those who learn things easily, who have exceeded the targeted level of learning, what are some indicators that suggest that they have exceeded that level of learning? That is one thing that we need to consider as a teacher in designing assessment. The targeted level of learning, approaching that targeted level, and exceeding that targeted level. When are some assessment opportunities? Of course, we can assess the students as a whole, as a class, but we can also assess individual students in the class. And if we cannot assess every one of them for any particular day, we might want to assess a few target students, maybe 8 of them, maybe 5 of them. So when can we do the assessment? Throughout the lesson. We can assess them during the exploration when you're working together. We can observe them from afar, listen to their ideas, the things they talk about. So I can assess as a class, how are they progressing towards the targeted level of learning? And I will have a sense of how well the class is doing. Are they moving to the targeted level pretty quickly? Are they struggling with that idea? I can tell, as a class, how are they doing as far as the targeted level of learning is concerned. And when they gather in front at the carpet area to do the structured discussion with me, I can assess individual students about their levels of understanding. Have they reached the targeted level? Or have they exceeded it? Or might they have some misconceptions? I can assess individuals during the structured discussion. During journal writing, if I give them a task that is telling, such as this, I can now get further insights into individuals' understanding of the current topic. And of course, during practice, initially guided practice, and eventually independent practice, I can tell on an individual basis, I can tell whether or not the students, the individual students, have reached the targeted level of learning. Or are they merely approaching it? Or have they exceeded it? And accordingly, I provide the necessary support or the corresponding level of challenge. I might also want to assess particular strengths of the different students in my class. And whenever there's evidence of that behavior, I would record that down. For example, some students are pretty good at working with other people. Yet other students are very good in coming up with interesting ideas. A particular student may have a knack of using diagrams, and yet another student may have that particular strength in reading the textbook to get ideas that might be elusive to them during the class discussion. I may want to look out for particular strengths of individual students throughout the year, and as and when there's evidence for it, that is my assessment information. And then there are some things that are general that I want to look out for throughout the year and across grade levels. I want to know, are students good at visualization? Are they good at seeing things beyond what their eyes can see? Are they good at generalizations? Are they good at looking for patterns, spotting patterns, and generalize the pattern? Perhaps even making conjectures, and when they have enough technical skills, be able to prove those conjectures. Do they have strong number sense? Are they the kind who are reliant on paper and pencil methods to do basic calculations? Or do they have that propensity to do mental calculation? Do they have strong number sense? Are they good at communication of mathematical ideas? I can see it in class where they explain themselves orally. I can see it when they write in their journals. And I want to know if they are strong in metacognition. I want to know if they are good at monitoring a multi-step process. Whenever something requires multi-step thinking, I want to know if they are good at that. Visualization, generalization, number sense, communication, and metacognition. Something else that I want to look out for throughout the year and across grade levels. For any concept, I want to know if they are able to tell me a story related to the concept. Can they also give me a diagram, a picture, a visual related to the concept? Can they explain the concept orally? Can they also explain the same concept in writing in their journals? Finally, I want to see if they have that ability to challenge themselves, especially on days they find that concept quite easy to understand. I want to assess for those 5 things: ability to connect to their everyday experience, ability to connect to a visual, ability to explain orally, but also in writing, and finally, the ability to challenge themselves, especially when things are quite easy. Those are some assessment opportunities that teachers have throughout a lesson in the execution of an anchor task. Specific to this lesson, we too can carry out assessment of product as well as assessment of process. For example, we can ask students to tell whether or not parts are equal. We can give them diagrams and ask them, are the parts equal? Or diagrams like that, and ask them, are the parts equal? Or diagrams like this, and ask them, are the parts equal? And you'll be able to say, yes, the parts are equal, or no, the parts are not equal. That is an example of assessment of product. We can also ask them to explain why parts are equal. And if they are able to do so, perhaps by saying, well, I can cut the square out and then cut the square up into two equal halves. And then I can arrange the pieces I get on top of the rectangle. Alternatively, they could show it to the teacher. Explaining why parts are equal is an example of assessment of process. Another way to assess is to ask students to show equal parts given a shape. Show me 2 equal parts. Show me 4 equal parts. Can you do it in 2 different ways? Can you also show me 3 equal parts? So that is assessment of product, but there is also a layer of assessment of process, especially if the teacher requests the students to explain why they have done it in a certain way. In the anchor task, where students were figuring out how 4 friends can share a square piece of art paper equally among themselves, what are some possible journal entries we can ask students to make? One category of journal we can ask students to write is what we call descriptive journals. In descriptive journals, students are doing mostly description. They might be describing how they solve a problem. In the anchor task that we are discussing, we could ask them to show some ways to solve the problem. So they could make some of the possibilities using pieces of paper and paste their creations in the journals. They are describing methods to solve the problem. Those who are able might be invited to make sketches, to make diagrams, to describe their solutions. That's an example of a descriptive journal. Another type of journal we can ask students to write is what we might call evaluative journals. In evaluative journals, students are required to make some kind of evaluation, some kind of a judgment. For example, in our current anchor task, we could ask them, can you make 2 columns and in 1 column put down some examples that you think are very easy for people to understand why the parts are equal. And in another column, put down some examples that you think other people might find it difficult to understand why the parts are equal. Can you do that? Can you make 2 columns? 1 column for methods that are easy for people to understand, and the other column, methods that you think other people might find difficult. Evaluative journals. Another kind of journal that we can ask students to write is what we call creative journals. In creative journals, there is some element of creation on the part of the students. For example, posing a problem might be an example of a creative journal. You could ask students, okay, we have solved the problem about 4 friends sharing a square piece of art paper. Can you now create a different problem, but about the idea that we were talking about in class earlier today? Can you be the teacher and create a problem that is similar but yet different to what we have done today? Creative journals. Another example of creative journal could be, can you come up with a couple more ways of sharing the square paper, but only include methods that you think nobody in our class have also come up with? Be as creative as you can. Come up with 2, maybe 3 ways of sharing the art paper among 4 friends equally, but try to give only methods that you think no one in our class have managed to get. Creative journal. Finally, investigative journals. In investigative journals, students are doing investigations and recording their findings in their journal. For example, in the anchor task that we have done, we could ask them to investigate how many different ways to cut the square paper up if I have given you this one, which has been divided into 16 smaller squares. The rule is you must draw along the lines. So no cutting across the squares, just along the lines, either vertically or horizontally. Can you investigate how many different ways to cut such a square piece of paper into 4 equal parts? Go, investigate. Investigative journals. So here we have seen some examples of journals that we can ask students to write in relation to the anchor task that we have seen today, which is 4 children need to share a square piece of art paper equally, and they are asked to think of different ways how that can be done. In teaching any topic, teachers need to have understanding of the curriculum, of the content, as well as of the pedagogy, and this thing that people call pedagogical content knowledge. Knowledge of curriculum. Teachers need to know at which grade level is the concept of equal parts being introduced. And we also need to know, subsequently, at which other grade levels do they continue to need that concept. The concept of equal parts is needed for students to be able to name fractions. When parts are equal, we can name them. And the name follows a certain convention. When one is cut up into two equal parts, we know the name is called half. When one is cut up into three equal parts, each part is called third, and so on. The concept of equal parts is needed whenever students need to name fractions. That is a curriculum knowledge that teachers need to have for the concept of equal parts. Teachers also need content knowledge as well as knowledge of pedagogy, and a combination of the two that we call pedagogical content knowledge. Teachers need to know, why did we use area of a shape to represent fraction? Why don't we use an orange? For the orange to be cut into equal parts, we are looking at the weight of the orange. In other words, we need to weigh the parts in order to tell whether or not the parts are equal or otherwise. Is that something that children can do to figure out whether the parts of an orange are equal or not? Why did we pick area of a polygon to represent fraction? What about the use of a rope to represent fractions? In this case, we know that the parts are equal or not, perhaps by measuring the length of the parts. So teachers need to know, why did we eventually choose area of a shape rather than the weight of an orange or the length of a rope to represent fraction? And is triangle a good shape to use? What about a circle? Is circle a good shape to use? Why did we in this lesson eventually choose a square? In the topic of equal parts, there are some things that we need to know as a teacher. Firstly, we need to know that equal parts can be congruent, but they don't have to be. Secondly, we need to know that students might use different ways to check whether parts are equal or not. They can check by folding, by cutting the pieces out, by cutting the pieces out and then cutting them up to rearrange the cut up pieces to hopefully overlap with the other shape, and by counting squares. And finally, we need to know why students need to understand the concept of equal parts. Equal parts is one of the prerequisites for understanding of fractions. Students need to know that when parts are equal, we can name the parts. In particular, if we let the square represents 1 and the parts are equal, we can name the parts based on a system, a convention. The system is that if two equal parts make 1, we call the parts half with a corresponding symbol. And if 1 is made up of 3 equal parts, we call each of the parts third. And of course, we have symbols for the word third, and so on. So when 4 equal parts make 1, each of those parts has a name of quarter or fourth. And likewise, fifth is a name of a part where 5 of that make 1. Those are some things that we must know as teachers in helping students learn the concept of equal parts. See you in another anchor task.